Hi everybody, today we'll talk about the Poisson distribution. You'll know when an experiment follows a Poisson process, and you'll also be able to compute probabilities for a Poisson random variable. Now Poisson comes from a person's name, Simon Poisson, who was a French mathematician. Now the definition is basically it expresses the probability of a given number of events on some fixed interval of time. And it's also got an average rate involved. There's some sort of average, which is independent of the time of the previous event that occurred. And the Poisson is represented by this Greek symbol lambda. And lambda essentially means your mean or expected value. And so the probability of exactly x outcomes over some interval is represented by this formula. This is equal to e to the minus lambda times lambda raised to the x power over x factorial. Now e is just a constant, and the other variables are part of the problem. So for example, here's a use of this problem. Say there are 3 mistakes on a person's math test. So we want to know, find the average number of mistakes on 4 math tests. So here's what you do. You got 3 mistakes to 1 test. It's equal to lambda over 4. So you essentially set up a proportion. And then you have lambda is equal to 12. And this number basically tells you the average number of mistakes on 4 math tests. So this is your average number of mistakes on 4 math tests. So this is a simple example. So there are others that involve a little bit more work, so I'll show you that. So let's look at this scenario where we have the email question. Okay, say for example, you expect 2 emails every 3 minutes. Every 3 minutes, all right? And then on the average, and that's basically any given day. So let's say on the average, that's the important part of this problem. Any given day. So we want to know, what's the probability that you'll get 4 or fewer emails in a 9-minute interval? Find the probability of 4 or fewer emails in a 9-minute interval. So what you do is set up your proportion. You have 2 emails in 3 minutes as lambda emails. That's going to be your average is happening in 9 minutes. Then you solve for lambda. So we want to know lambda equals what? So you have 3 lambda equals 18, or lambda equals 6. So that's going to be the average, or expected value. So you can expect about 6 emails to pop up. So this is how you would interpret this. In 9 minutes. Okay, so then we still have to answer the question, well, find the probability of 4 or fewer that's going to pop up in 9 minutes. So what we have found so far is the lambda, but now we have to ask the rest of the answer the rest of the question here. So let me erase the top part of this so I have some room. So now we want to know the probability of x being less than or equal to 4. And that's because we want 4 or fewer emails in 9 minutes. So that's going to be probability of 0.6 plus probability of, so no emails in 6. Or no emails, then probably a 1. 6 plus probability of 2, 6 plus probability of 3, 6 plus 3. Then for each one of these terms, we can substitute and use the formula. So this is equal to e to the 0, 6 to the 0, e to the minus 6, all over 0 factorial, plus 6 to the first, e to the minus 6, all over 1 factorial, plus 6 squared, e to the minus 6, 2 factorial, plus 6 third, e to the minus 6, with 3 factorial, plus 6 to the fourth, e to the minus 6, over 4 factorial. Each one of these terms can be put in a calculator to compute and simplify, and when you do, it's approximately equal to 0.0025 plus 0.0149 plus 0.0446 plus 0.0892 plus 0.1338. If you add all of these up, that's approximately equal to 0.2851, which is approximately equal to 28.5%. So the probability is 0.2851, which is about 28.5%. And so you can expect, if you can expect 2 emails every 3 minutes, then the probability of 4 or fewer emails in 9 minutes is going to be about 28.5%. And intuitively, it should be less than 50% if you think about this. But there's another way you can do this, which is with a calculator. You can do the binomial, actually Poisson. The Poisson CDF, and plug that data in. And when you do, the CDF is a cumulative number, so you would put in 6.4, and that's approximately 0.2851. Because it's cumulative, you can do it directly, because it starts with the first term and goes through the last. But you can also do it manually if you have to. Start from the very first term and just add cumulatively until you get to that 5th term. So here's the alternative way, in case you forget how to use the CDF. You would just do Poisson PDF 60 plus Poisson PDF of 6.1 plus, I'll put them all down, but then you do Poisson PDF of 6.4. And doing this way, you'll also get the same thing. What's nice about the calculator is it saves a lot of time with some of these computations that get very complicated very quickly. Well, that concludes our discussion on the Poisson distribution. So we've learned what types of situations you may need to use Poisson for. It involves an average. And we also know how to compute Poisson probabilities. Thanks.